This is my theory of everything and how this puzzle world functions. When entering the vault, the statement from decryption, "Don't trust anyone," and "They are watching." Take it seriously, don't trust the hints. This is how you pass this door. Once pass, there are 3 doors you must go through to get to the vault. In order for my brain to save compute, I removed Jimmy from the image and replaced him with a green box and defined green box as Jimmy. Stage 1 door gives the framework to pass through other doors. In order to rebuild the framework, observe the environment. This is the main monitor that gives everything, which is n to the power of 3 equals n to the power of 2. This defines this world's states, which are binary. This monitor is the one we need for everything due to BSpot stating, sometimes you don't get what you want, sometimes you get a little, and sometimes you get everything. We want the monitor that gives us everything, in which you will understand why this monitor is everything. In order to add logic using this monitor, observe there's 1 lights blinking. The blinking can be used as logic of 0 and 1. There's a total of 33 total blinks of zeros and 1's logic that we can use to build our logic board. How the logic works. First, you must understand this equation, which I discovered on my previous video, which states word scramble less than j less than minus 6,284,363. Since j represents as a 10, based on using A1Z26 cipher in reverse, that means we can define 9 objects with values of less than j. I generated a list so you can visually see how the equation functions. If you add all numbers of yellow, you get a total of 45, which is not good for the logic board, as it can go up to a total of 33, which means only 33 values. The way to fix this is if you observe the lights, it just conveniently stops at 7, which adds up to 28, as this part of the light doesn't function as a constant. The last 2 lights at the bottom can conveniently be defined as 2 and 3, which equates to 33. The reason for this is due to BSpot quote, "A 2-triangle triangle is a triangle, so is a 6-triangle triangle, but 5? That's no triangle." Observe the triangle I've circled. There's 2 here. We can define the 2 triangle as 1 object and define it as n to the power of 2. BSpot quote, "In a count the triangles, you find individual triangles on a grid." The 3 triangles here is defined as a triangle as it's a 3, which is half of 6 triangle. Are you starting to notice something? N to the power of 2 and n to the power of 3. Since the triangles, by this definition, in total is 2 and 3, this fulfills the 33 binary logic by stating 2 and 3 triangles can be used as part of the addition logic. Here's even more proof. If you observe Nolan's hand signal, its representation of 0, and the action sequence starts on right to left due to the inverse function of this monitor, and from observation, it's common sense due to this specific light sequence displacement. For more context on why it's inverse, please watch my video of when I got lost in the world of 4-doku, where time moves 5 times faster, but you have no clue what's going on and forget the priority, the $1 million in the vault. With word scramble less than j, we can add 9 elements to the yellow lights. To further proof this is real, observe the lights here, which defines objects by proximity. Thanks to the rules we used, we can align it with this equation. With this, we can solve the grenade problem. If you observe the question mark, notice mixtures of both white and yellow. When Jimmy throws the grenade, this represents upward motion and downward motion. If you observe the yellow door, it requires both upward and downward motion. My alphabet list gives me smock plus yellow, which we can define as n. This equals 2,759. The reason E is removed is due to both none defined on the 9 elements and BSpot stating, "Number the letter from 1 to the end, then cross out some." If you look at how S is defined, it's a 1. Since 1 is n to the power of 2, if we add n, which is yellow, we get n to the power of 3, which equates to 2 on the formula. S is an object with multiple function, which makes sense as it's literally on the triangle that inputs power. The code 2759 allows us to go to the next room. The second door is a zigzag pattern. Observe Beastbot quote, "The answer is in a zigzag pattern in the 2 neighboring columns with no numbers." My equation states that J is a constant, and there's only one constant here that matches J, which is Jimmy, and he's between the zigzag door. He's also not a number since we only define 9 elements as numbers, which are yellow. I converted Salesforce into numbers where J is inputted. This is what it looks like. Due to separation of words, J is the middle. This equates to 181J52. Remember, this statement still remains true from Beastbot, so I didn't add the full Salesforce letters. It also makes sense because S serves also as 0, which equates to left movement, and if you treat it as binary logic 1, this would equate right movement. Now that we have this equation to open Salesforce's door, we can move to the final door where the vault is. The laser room is where things gets interesting. Quote from Beastbot, "It matters where the lasers start, not where they go. If you observe my image, 10 red lasers hits the dot. 2 lasers didn't hit the dot, instead are directed to these 2 screens. The red loading is a good indicator. From the ear where the red cross mark shows that T is removed, so if we define value of red, we can remove the red lights. You can observe here my define alphabets and colors. There's only 3 objects to red, and the objective is to shut down the lasers. I've imputed I, H, and G in order due to G being the last light to glow, and it's pointing to the ears, which means shut down due to red X. The last part, to checkmate Jimmy. This definition is from my previous video of how I defined chess and objects on the vault due to evidence of Beastbot and the relation of 136 move match from Game 6 of the 2021 World Chess Championship. I couldn't define the knight, which was what checkmated the king. In this case, in order to checkmate Jimmy, I define knight as 9, 6, I, G, H based on my collection of decoding methods. When you add up all the sequence, the final code is here. I like to thank the people who admired my solutions. It means a lot to me as it shows I am not going insane. Thank you, and always remember the best questions is to strive for.